We are going to present here the semi-continuous reactor, which is called fed batch. It's a mixed reactor which is fed by a flow, an entrance flow, we will call it Q, and SA is the concentration at the entrance. X and S are the concentration inside of the reactor, V the volume. S bar is the concentration of substrate inside. It's constant. It's optimal to have a growth rate optimal around mu max. The initial conditions are X0, V0 and S bar. X and V are function of the time and S bar is constant. The volume of the reactor is varying during the time because the reactor is fed. We are going to represent the expression of X, V and Q in function of the time. To do that, we will use a global balance. Volumetric global balance. The term of accumulation is dV over dt is equal to Q, the entrance flow. The biomass balance. The accumulation term is dxv over dt. It's equal to the production term, R triple prime X times V, and X and V vary. X times V, it's mass of X, of biomass. R triple prime X, it's mu times X. X times V, it's mx. So we can write it in that way, dmx over mx, it's mu bar dt. We can integrate this expression between two limits mx0 mx and 0 and t. And mu bar is constant, so we can take it off the integration. The integral of dmx over mx is Neperian logarithm of mx over mx0, and the integration of dt is t. If we apply the exponential to the last expression, we can make disappear the Neperian logarithm. So xv is equal to x0 v0 exponential mu bar t. We can see that the mass of biomass is increasing during the time with an exponential law. Let's do now the balance material over the substrate. So the accumulation term is dSV over dt. It's equal to the entrance term Q times SA minus the consumption term R triple prime S times V. And S is equal to S bar is constant, so we can take it out of the derivative. We can replace R triple prime S by R triple prime X over the yield. So, and we can replace dV over dt by Q. So we will have this expression R triple prime X, it's mu bar X. We can put Q in factor and we will have this new expression. We can isolate Q and we can replace X times V by its expression in function of the time. And we will have at the end this expression of Q in function of the time. All the other terms are constant. We can see that the volumetric flow increases exponentially over time. We are going to deduce from it the expression of the volume in function of the time. For that, we use the global balance dV over dt is equal to Q, and we can replace Q by its expression we found previously. expression in function of the time. We are going to isolate dV at the left side of the relation and dt at the right side of the expression. We are going to integrate this differential equation between two limits, dv, the limits v, o and v, and the time 0 and t. The group of terms circled here in red is constant, so we are going to take it off the integration. The integration of dv is v, and this term, this constant term, it's take it off the integration, and the integration of mu bar exponential mu bar t, it's exponential mu bar t between the two limits 0 and t. So we can isolate v and we will have exponential mu bar t minus 1 because exponential of 0 is 1. So we have here the expression of the volume in function of the time. The volume increase in function of the time. We are going now to demonstrate the expression of x in function of the time. We are going to replace v by the previous expression we found, and we can simplify v0. So we will have this last expression of x in function of the time. We see that the biomass concentration increase in function of the time. We made a graphic representation of x, v and q in function of the time. We used some specific data to make this graphic. We can see that x increase between 5 grams per liter to 80 grams per liter. The volume increase between 25 liter to 120 liter, and the volumetric flow increase from 2 liter per hour to 22 liter per hour. We can see that with a fed batch we have to anticipate the volume of the reactor, and we have to take care not to cause the reactor to stall when feeding it.